Okay, so now hopefully you feel comfortable with very simple conversions involving them all fitting into the overall learning goal, which involves them all, both understanding what it is and also being able to use it to make simple conversions between moles and molecules, between molecules and mass if you have a covalent compound, particles and mass if you have an ionic one. What we want to talk about for the last section of the chapter is elemental analysis. And this is a procedure that chemists can use to identify unknown substances. For example, if there's a murder and at the crime scene they find an unknown substance, they're going to do elemental analysis to try and figure out what it is. And there's a lot of different ways to go about this. And one type is percent composition. This allows you to determine the percent by mass of each element in the compound. And it's really very simple. It's something that you actually have seen previously. If, for example, you have some crackers as a snack, if you look at the nutrition facts in regard to serving size, servings per container, as well as the major food groups that these crackers make up, such as total fat, cholesterol, sodium, etc., you will see that they are given as percent compositions. For example, with these crackers, 5% of the daily value, you're hitting the total fat category, 9% for sodium. For those of you who really like soup, if you look at soup labels, you will see that they're extremely high in sodium, which is really sodium chloride, table salt, and you don't want to overdo it with your salt intake. Your total carbohydrate, then you're getting 3% here, and dietary fiber, that's actually good for you. But you can see these different percent comps with a lot of different things that you do each and every day, whether it's a nutrition label, whether it's your grades. You know that your exams make up 50% of your grades. Your labs make up 20% of your grade. Your quizzes 25, your classwork and homework 5%. That's percent basis as well. You also can see it, for example, with pennies. Pennies have changed over the years. Back in the 1800s, pennies were pure copper. It became too expensive. And after 1864, the penny was made up of bronze, which is 95% copper and 5% zinc. And then after 1982, when we saw this in the lab, the penny is actually just copper coated. It's mostly zinc, 97.5% zinc. It's just much cheaper to manufacture. And that's why when we did the very first lab of the year, you found that the new pennies had a density very close to that of zinc. And that's because they are made primarily of zinc. In Canada, it's a little bit different. It's 94% steel. Steel is iron with copper atoms in the interstices making up an alloy, but that's more advanced than what we want to get into. So percent comp very much affects you each and every day, and we'll talk about how to determine the percent of each element in a compound. And it's very simple. You already know how to do all the pieces, and now it's just a matter of putting the pieces together. Very, very simple. For example, let's say that you're taking a quiz, and out of 10 questions, you got 9 correct. How would you figure out your percent on that test? You got 9 correct, and there were 10 questions. Chris? And then, to get a percent, you would... Well, 9 over 10 is 0.9, so how would you get a percent? What would you multiply by? 100, okay? And then you'd get 90%, exactly. So that's how you could figure out your quiz score. 9 correct over the 10 questions times 100. Same thing here. exactly the same. When you're trying to determine percent composition, that is the percent by mass of each element in the compound, you first write the chemical formula. Again, you're masters at writing chemical formulas. That should be very easy for you. You'll need to determine the formula or molecular mass of the compound, formula mass for an ionic one, molecular mass for a covalent one. And then to get the percent composition, you look at how many of that element is present in the compound. You multiply it by the molar mass of the element. You divide it by the formula or molecular mass. And then once you've divided, you multiply by 100. So let's take a look at working through a couple of these problems, and that's going to finish us off for today, and we'll link it into 2 basic concepts for next time, and then we'll be able to do the lab as well, which deals with percent of water in a hydrate. So when considering this first one, the first compound is water. Is water covalent or ionic? Covalent, 2 nonmetals sharing electrons between them. So for example, if we had a water molecule, H2O, we want to figure out the percent of hydrogen and the percent of oxygen in water. We've written the chemical formula. We need to figure out the molecular mass for a covalent compound. We have 2 H's and 1 O. 2 times 1.0079 grams per mole. 1 times 15.999 grams per mole. And here we want to get to 3 decimal places. We get 18.015 grams per mole. The molecular mass of water is going to come back again and again. It's a good one to just know and not deal with, but you can always derive it. Now we want to figure out the percent of each element in the compound. Now this first one I'm going to write out in longhand so you see all the pieces, but then I'll show you how you really can make it a little simpler for you. Otherwise you're just writing the same thing again and again. To get the percent of hydrogen, we're going to use this piece because we had 2 H's times its molar mass over the molecular mass, and we're going to multiply this by 100 to make a percent. Usually with these types of problems, I ask you to find it to the nearest hundredth just to make it easy in regard to sig figs. So this times this over this is going to give you a percent composition of 11.19% hydrogen. Now if you only have 2 elements, you can just do 100 minus the other piece, but we'll go ahead and derive it for oxygen as well. So what would I do differently for oxygen than I did for hydrogen? Would the denominator be the same? Sure.
The denominator would stay the same, but the numerator would be 1 times 15.999.
You got it. So the only thing different is the numerator. We have 1O with a molar mass of 15.999 grams per mole. You'll see the units canceling here. Times 100. and that's going to be 88.81% oxygen. Piece of cake. You already know how to do all the pieces. Now it's just a matter of dividing and multiplying by 100. Let's do another one. Let's say, for example, we had iron 3 sulfite. And again, the formula writing will be critical. You're very strong with your formula writing. You mastered this in chapter 5. We've got iron 3 sulfite. This one I'll write out a little bit differently so that you can see how you can just make it a little simpler for yourself and not keep writing the same thing over and over and over. We have 2 iron. 3 times 1 is 3 sulfur. 3 times 3 is 9 O's. Just like we did at the beginning of the period. We get the molar masses off the periodic table. And now we're going to get the formula mass, 2 times 55.847 plus 3 times 32.066 plus 9 times 15.999, and that's 351.883. It's easier to write it here. And then I like to just squiggle down. And then you don't have to write as much. So some of you may prefer that, because you don't want to write the same thing over and over again. That's a waste of time. So this times this divided by this, and then times 100 is 31.74%. And again, I usually ask for the 100th place. Your percent should add up to 100% or very, very close to it, depending on the rounding. So with percent composition, it's how many of the element you have times the molar mass divided by the formula mass times 100. Oh, I'm sorry. Can you see now? Okay. Percent composition, percent by mass of each element in the compound. Yes, yes? Piece of cake? Okay. I want you to try, I don't know if it's going to show on my screen. I want you to try this last one. I'll show you the answer in a few minutes. And on your classwork now, you also can do number 17. And that will set us up with two very tiny lessons, or two concepts. One lesson for Friday. I'll introduce the lab concept as well, and we'll be ready for a quiz on Monday. That should work great. Questions here? Percent composition looks very basic. Yes? Questions? You're good? You just have to practice. Practice, 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 right? Chemistry is not a spectator subject. You've got to practice. So trisodium dichromate, I'll put the answer up in about 5 minutes. You can do through 17 on your classwork, and if you do all of those problems, you should be highly successful for our next lesson and our quiz on Tuesday for period 3. The dichromate is a polyatomic ion on the back. Look under D. A little bit tricky because there's chromate and dichromate. Do you see it? Okay.